Hi friends, you're welcome to today's lesson. In today's lesson, we're going to be looking at the second worked example on equations under modular arithmetic. In our previous lesson, we looked at the first worked example. We worked on, linear equation, and today we're working on what looks like, a simultaneous equation. So look at what we have right here on the board. We are asked to solve for x in 5x plus 3 equals to 4 in modulo 7, and next we have a 3x equals to 2 in modulo 7. Now observe something, they are both in the same modulo. Now how do we do this? Now it's very, very easy for us to solve this. So first of all, we're going to solve each of them. We have two equations. This is the first equation, this is the second equation. So 5x plus 3 equals to 4 modulo 7. We'll have a 5x. Now you're going to send the 3 to the other side. 5x plus 3 equals to 4 modulo 7. So we'll have a 5x. When 3 crosses, become 5x equals to 1 in modulo 7. That's the first. If it's possible for you to simplify whatever you're given, you can simplify it to make things easier for you. So 5x equals to 1 in modulo 7. Then 3s equals to 2 in modulo 7. Now this is very, very simple. Since you're talking about the same modulo operations, assuming you're talking about different modulo operations, there's no problem. What you just have to do is you just have to create a table, a multiplication table, using each of the modulos given to you. But for the fact that we have the same modulo operation, we're going to be using just one multiplication table, which is 7. So 7 times 0 is 0. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21, and so on and so forth. I could add more to that. Assuming this is modulo 8, then we're going to create another table getting the multiples of 8. So now we're talking about the same modulo. This is okay, know what we're about to do. So 5x equals to 1, 3x equals to 2. So we could start with any one of them. I could start with this. So we're going to use this multiple first. We're going to start with this, which is 0. So if you add 0 to 1, 0 plus 1 is 1. So 5x equals to 1. What are we going to get? 5x equals to 1. The Bible says by 5. That's about 0.2. That's s is 1 over 5. So when you substitute x, which is 1 over 5, into equation 2, that'll give us 3 times 1 over 5, which is, 3 over 5. 3 over 5 is about 0.6. When you convert 0.6 to modulo 7, there's no way you're going to get 2. So this can be, what we're going to use. So let's use 7. 7 plus 1 is 8. 5 and 8 is 1.6. So there's no point. Let's check the next 14. 14.1, 14 plus 1, I beg your pardon, is 15. So 5x equals to 15. The Bible says by 5, x is 3. So if s is 3, substitute s equals to 3 into equation 2. So 3 times 3 is 9. 9 in modulo 7 is 1 remainder 2, which is 2 modulo 7. So it means s is equal to 3. This is what we are looking for. The value of x is 3. Absolutely, simple. So if you're talking about different, modulos, let's say this is modulo 8, we're still going to use the same result. It's just that we're going to create, a multiplication table for 8. We're going to have the multiples of 8 displayed on the other end. So we use each of the multiples added to this. That will give us the x. So whatever the x is, we fix it into the second equation to see if the value of x is correct. So whatever the value of x is, when you fix it into other equations, you're going to get the same result as stated on the other side. So we can also do the same thing. We can also check this. We could start with this. If, let's use 7. 7 plus 2 is 9. 3s equals to 9. Divide both sides with a coefficient of 3. So 3 divides 9 is 3. So what do we have? S is equal to 3. 5 times 3 is 15. 7 and 15 is 3 remainder 1. 1 modulo 7. So x is equal to 3. That's what we are looking for. As easy as that. So I'm very sure that you gain 1 or 2 things from today's lesson. I would love you to give me a follow on Facebook or Revelation Hub, and subscribe to the very channel at Edge Mosaic. And please share the lesson also with others. See you in the next lesson. Thanks and bye for now.